Hey, good evening, everyone. We will get started in next 1 to 2 minutes. Just to make sure, is everyone able to see my screen and hear my voice? Great. Yeah, so we'll be starting in 1 to 2 minutes. So Chaitanya has a question. We can do project in any of the language, Pig and Hive, right? Yes. Yes, Chaitanya, you can use any language. Okay, so let's get started. So yesterday we had started with HBase. We saw about how HBase stores data. We saw concepts about what are column families in HBase and how you can add columns. So there's no requirement of any schema in HBase. You just define the column families. You can add columns on the fly when you insert data. So I can have a few rows which can have, let's say, n number of columns, and the remaining rows can have m number of columns. Right, so the number of columns is can be different for every row which you add in HBase. Just the column family should pre-exist. Hey Manish, good evening. Right, so we just started with a brief introduction of what we did last time. Okay, now as I mentioned, this HBase is very similar to a JSON file. It's a key value store. So once you define a column family, the columns and the values for that particular column which you define, you can imagine that it's stored as a JSON file. So let's look at an example. Okay, so simplifying HBase, it is a simple map. So as I mentioned, HBase is very similar to your Java hash map, or you can say a hash table. We discussed a few properties about this hash table, that whatever you enter data in HBase, it is always sorted. So what your HBase will do, as soon as you add data to a particular table, it does not write to the table directly. It first writes it to a WAL file, a WAL file. That basically is a write ahead log. From that WAL file, your data goes to a mem cache. That's a mem store basically. Mem store is the place where your data would be sorted. Because for sorting data, I require some memory. I cannot sort data which is there on disk, right? So I require some memory to store. So this mem store is a place where data is sorted. From your mem store, when it reaches a specific limit, ideally 64 KB, your data is directly pushed to your HDFS in the form of your actual HBase storage. That file is called as H file. Whenever you're trying to access data, your client first goes to the H file, which pulls the data in something called as a block cache. So the most recent read data is always available in the cache. Hey everyone, am I audible now? Great. I think there was a network glitch. All right. All right. So I was discussing about how HBase stores data. Okay, so it's a JSON format kind of a thing. You can imagine it to be a JSON format where you define key value pairs. Okay, all the column families. So whenever you're entering data, the columns, there is no need of defining the columns. You should just define the column family, and the columns you can define it on the fly. So I can have a few rows having, let's say, 5 columns, and some of the rows, let's say, having 20 columns, some of the rows having 70 columns. All right. So per row, I can change the number of columns. The only prerequisite is your column family should pre-exist. And whatever data you enter into HBase, the data is automatically sorted by your HBase and then stored. So we have seen a reason why the data sorting is required. The actual reason is, so in your HBase maintains a special catalog table, basically 2 catalog tables, root and meta. So this table ideally helps you to identify that for a particular table, when it is broken into multiple chunks, and these chunks are called as regions. So this meta and root tables helps you identify where my actual region is residing on which region server, all right, based on the keys you provide. So your HBase will break your data. So first it will sort your keys and values, all right. Based on sorting, it definitely knows that per region, what is my start key and what is my end key. So whatever data I'm trying to read or write, it will directly go and target the actual region server instead of doing a full table scan. That's why sorting is required in HBase. All right. So it is HBase, to be simplifying HBase, it is just like a simple map, and this map is always sorted on the basis of keys. All right. So this is a sorted map. The sorting is based on bytes. Okay, it's a byte sorting. So you can say, so let's say I have these values. Okay, let's say I have these values. Is this value sorted? Can anyone tell me? Are these sequence which I have written, is the sequence sorted or not? I'm talking about byte sorting, not number sorting. Right, so everyone says this is sorted. Ideally, if you talk about byte sorting, this is not sorted. Right, if you look in terms of numbers, yes, this is sorted. But HBase does not, your row key can be anything. Right, you can, your row key can be an integer value, float value, string value. It can be an object. Ideally, anything can be a row key. All right, so this sorting happens on the basis of bytes. So this is not sorted in terms of your HBase. If I write a sorted format for this, it looks like this. This is byte sorting, right? This is byte sorting. So if you look in terms of bytes, your 1, after that, anything which starts with 1 will come then, right? Then your 11, 12, and then other values. So this is byte sorting, right? So when we'll insert data to a HBase table, you will get a clear understanding of this. You'll get a clear idea how this sorting helps, how this sorting looks like, all right? So this is not sorted, though it seems to be sorted, but this is actually a sorted way your HBase stores it, because it is byte sorting. It is not numeric sorting. All right. Okay. So this is how you will create. Let's say I have a table. All right. So whenever you insert data into that table, you first have to define a row key. Every row going to your HBase table, it's mandatory that it should have a row key. Without a key, you cannot insert data to HBase. This row key must be unique. All right. If the row key is not unique, what will happen if you, let's say I have a row with a row key, let's say EMP1. If I try to insert another row with the same row key, it will actually update the previous row key. Okay, so if you use same row keys, it will update the previous data. If you use a unique row key, it will add a new row. Okay, so you should be very specific in deciding what your row key should be. The best part is row key can be anything. So in our case, what we do, whatever, so we generate row key based on timestamps. Okay, so there's a guarantee that my row key won't be repeated. Okay, so you should choose your row key according to your application. All right. Now, if you see this personal, you can consider this to be a column family. Now, inside this personal column family, I can add n number of columns I want. So I can add, these are my columns, name, age, password. All right, and these are my fields in my column. Now, if you see, my password shows 2 fields. Now, what is this number which is getting displayed? This is a version, right? So whenever your data is inserted to HBase, it is by default versioned. Every cell in your HBase table is versioned. Okay, I mentioned yesterday, cell is basically an intersection of your rows and columns. So every cell is versioned. you can define your own versions. If you don't define, the default versioning which your HBase uses is a timestamp. So let's say I insert data. I insert the same data with the same row key twice. I don't change my name and age. I just change my password. So there will be two versions of my password which would be stored by my HBase. Yeah, so Minesh says, so it will be visible with a colon. Yes, Minesh. So your column names are visible with a colon. Okay, so it would be column family colon your column name and then the actual value. Okay, so Rahul has, while fetching this version value will retrieve. Yes. So if you by default do a select on your particular HBase table, it will always show you the latest versions. Okay, it will show you the latest versions. You can query the previous versions also. Okay, but if your table is going a major compaction, so remember we talked about compaction yesterday, minor and major. So if your table is undergoing a major compaction, the previous versions are deleted. Okay, so just to basically compact the H file size, your previous versions are deleted. Right? So every data, every column's value which you put, it is by default versioned. Okay, you can have multi-dimensional columns. Okay, like I can have a column family can have multiple columns, a column family can have no columns, a column family can have nested columns. So all of these are supported in HBase. It's just the applications, it just basically depends on your design which you do. Yeah, this is fine. So we'll discuss this. You will get a clear idea when we when we create a table in HBase and we insert some data. Right? So how does your tables look like? So this part is also already discussed. We'll just go through it. So every table, okay, which you define has multiple rows, and each rows has a unique row ID, and this row IDs are sorted. So it consists of number of columns, consists of any number of versions. Okay, so you can insert, whenever you can update your table row multiple number of times. Every update will basically maintain a version of the previous value. Okay, and when you insert into data column, so column family exists, column does not exist. So when you insert data, column would be automatically created. And columns in a family are sorted and stored together on your HTFS. So whatever things we have discussed about your wall file, your H file, mem store, block cache, this is per column family. Okay, so Chaitanya says, what is the frequency of compaction? So this frequency you can configure, Chaitanya. Okay, you can configure at what frequency your compaction should happen. Ideally, minor compactions does not disturbs your clients. Okay, minor compactions does not have a huge lag in your reads and writes. If you're doing a major compaction, all right, until the major compaction happens, your clients would be affected. Your reads and writes would be affected because major compaction takes a lot of time to finish, and ultimately it uses a lot of disk I/O. All right. So usually it's an administrator who schedules this compaction. Usually major compactions are scheduled for weekends or nights. Yes, it is like a maintenance activity. Okay, so it doesn't matter your data is compacted or not, your HBase is still fast. But if you compact it, that's an other direction of optimization you're giving it to your HBase. So it's good to compact, right? Ideally, you should prefer minor compactions because it keeps your previous versions also, right? Major compactions deletes your versions. Okay, so it's like a maintenance activity, true. Okay, so let's take an example. All right, so we have a table created. Okay, you can consider this to be again an employee data. We have two column families, personal data and demographic. All right, so when we insert data to this particular table, if you see every row ID is unique. And the columns corresponding to each column family you can define on the fly. So personal data has 2 columns, name and address. Demographic data has 2 columns, birth date and gender. So how HBase stores this in terms of your HDFS storage? So what your HBase will do, so when you insert data, so your per column family wise, your H file would be created. So if I have 2 column families, I would be ultimately having 2 sections. So if I have 2 column families, you can say I would be having 2 wall files, I would be having 2 mem stores, I would be having 2 block cache, and per column family I can have multiple H files, right? So this is, and when it stores to your HDFS, your H files, there could be multiple H files for a column family, right? It depends on the amount of data you're inserting into that H file. Typical size of your H file is 64 KB. So let's say I insert 1 GB worth data into a single column family. Ultimately, in terms of HDFS, they would be stored together, okay, under a same directory or a same location you can consider. And ultimately, it would be distributed. It's going to HDFS, it would be distributed. All right. So this H file created for this first column family and H file for the second column file would be stored at different places. Okay, that's what I meant by your HBase is a column family oriented database. Okay, column family wise, your data is stored into your HDFS. Right, so this is how it looks like. So when you select from this table, so there is no query like select star. There is a specific query to display all the data. The query name is scan. Okay, SCAN. So if you do a scan on a table, it will display all the data for that particular table. So this is how it looks like. So it displays the row. Just take an highlighter. It displays the row, and in your column and cell, it basically displays your. So if you see data colon 1, so data is a column family, 1 is your actual column. Right? If you see data colon 2, data is your column family, 2 is your column name. And the actual value for this column 1 is this value 1. And that 1 is gone to the next line. But the actual value for this particular column 1 is value 1. Okay, and if you see this timestamp is automatically generated by your HBase. Okay, so row keys are unique for each row, identifies each row. Column family colon column qualifier. So less number of families gives faster access. So ideally your design of HBase should be such that you should have less number of column families. It will enable faster access. Okay, so if you consider, right, so the more column families you create, the more wall files it will create, the more H files it will create, the more mem store would be required. Right? So less number of column families is an optimized way to use HBase. Families are fixed, column qualifiers are not. Right? So column families which you define, these are fixed. Okay, so you have to define it upfront. When you define a table, you have to define a column family. And the columns, which is your actual column qualifier, which comes after this colon, that's called as a column qualifier, that can be dynamic. You can define it on the fly. Values, various versions of values are maintained. Scans shows only recent version. Right? So when you select from a table, when you scan a table, it will show you just the latest version. Right? And ideally, why it is storing versions, why this versioning thing is required in HBase is, see, ultimately data is getting stored to your HDFS. Once my data is stored to HDFS, I cannot update my data. Your HBase says it is able to update. Now how HBase manages updates? See, ultimately it is HDFS. I cannot update it. So what an HBase does, it is not updating a file internally. Right? It just adds one more row with a new version. Right? This is how it is managing updates. So it is not going and updating a specific file. It is just adding one more H file with the latest data for that particular column family and column. When my major compaction will happen, this entire, let's say I have 10 H files, this entire 10 H files would be merged together into a single H file. There is a place, so here is an opportunity for your HBase to make your previous columns to delete. Okay, that's why it deletes your previous versions. right? So your HBase shell, yeah, so we would be looking at an example for this. So we can skip this part for now. All right, now you can interact. How do you interact with HBase? So there are two ways you can interact, either through a shell, that's your command line, or through your programming language, right? So HBase gives you an API for interacting through Java. All right, so it has a package, it has an API. This is a package, org.apache.hadoop.hbase.client, and you have multiple classes inside this package. So the basic class which is there inside this package is htable. Okay, so when you're using your HBase through Java, htable is a class which will basically define your table. So it is recommended that you create htable instance only once, one per thread, and reuse that instance for rest of lifetime of your application. So this is in terms of your application when interacting through Java. Okay, so when you're creating an application, when you want to insert multiple rows, fetch multiple rows from a single HBase table, it is recommended that you create only one instance of htable, and do how many number of times you want to do read and writes, right? So this is an ideal, it's just a practice you should follow. There's no issue in closing the htable and reopening an htable. There is no issue in this, but it's a standard way of accessing your HBase through Java. So there are multiple classes available from Java in your Java HBase API for using HBase. All right. Okay, so that slide is later. So I'll show you that slide first. Yes. So there are multiple classes available for your Java to interact with HBase. So there's a class called as configuration where you specify all your config details, just like your Hadoop, right? When you are accessing Hadoop through your Java client, you specify all the configurations. Okay, there's a class called as HBase admin. So this is basically helps you to manage administrative tasks through Java. There is HBase descriptor that have details of the table. For example, when you describe a table, so it shows you the columns and so it shows you the column families, the rows, okay, all of these things, the schema basically of your table. You can get that schema using HBase descriptor. Again, it's all our classes in Java. And htable, it's a table instance which you get in Java. Okay, it is used to put, get, scan your table. All right. So going to previous slides, which we skipped. Yes. So data loading techniques. So how do you load data to HBase? So first way is through your HBase shell, the most simplest way. Second way is you can load an HBase table using pig. So pig. So when you say, so remember pig has something called as pig storage class, right? So using pig storage, you can store your HBase data. You can store your pig data to HBase. So let's say I have an application where I want to read some files from HDFS. I want to process it. The processed output, I need to store it to HBase table. So I can use pig for that. I can also use scoop. Okay, so basically what is scoop? Scoop is used to import data from your regular relational databases to your HDFS. So scoop also gives you additional functionality that you can import data either to a HDFS file or to a Hive table or to a HBase table. Right? So scoop is able to load data to a HBase table. And one more way is using client API. Okay. HBase, so if you go to your HBase website, your Apache HBase website, they have created some tools which is easily readily available in your website itself, which is used for loading bulk data. So if you use any of these, so let's say you use client API or your HBase shell. Using this, you can insert data row by row. I cannot insert thousands and millions of rows at a single go. Right? With pig and scoop, yes, that is possible. But let's say I have a file. Let's say I have a CSV file. I want to insert that CSV file to my HBase table. Okay, so I would ideally insert it row by row. HBase gives you some tools which can be used for bulk loading. Right? That's just an additional thing which is coming up with HBase. Right? Or what you can do is, so as mentioned earlier, you can use Hive, correct? Hive and HBase can be integrated together. So what you can do, you can create a Hive table, pointing to an HBase table, and you can bulk load a Hive table. Ultimately, it will internally bulk load your HBase table. So there are multiple ways to bulk load your HBase tables. Okay, this is a typical example. So what happens if you, how to do an scoop import? So this is a command. Okay, this is a typical scoop command. I know we haven't seen any example of scoop, how it works. So it's just a command. You say scoop import, you give some options to your scoop command. So you give a connection string, like what database your scoop should connect to, right? Which is basically your source of your data. Okay, you can specify username and password for this particular database using hyphen hyphen username and hyphen hyphen password. You can specify which table you want to scoop, which table's data you want to import to, either HBase or Hive or HDFS. So these destinations are three. You can have three destinations in scoop. It can be a HDFS file, it can be an Hive table, or it can be an HBase table. Okay. Then you can define, so if it's an HBase import, you can define HBase table in this way. So these are all the options which are by default supported by your scoop. You can define column family, row key. If your table pre-exists, or let's say a table, HBase table which you're defining here, the target table, if it does not exist, you can specify this option, create HBase table, HBase create table. So what it will do, it will automatically create the table, do a scoop import for you. If you want to import to an existing table, so this last option is not required in your scoop command. This is just a scoop command. It's very, so we'll see an example of scoop, right? We have an example how to use scoop. So Rahul has a question, is row key unique column of table? No, Rahul, it's not a column. Okay, you can consider row key as a primary key, primary ID. Okay, so a single row key can have multiple columns. Okay, row key itself is not a column, right? Row key, so let's say this way. So when you define an HBase table, you can define a column family here. This column family can have multiple columns, column 1, column 2, column 3. An identifier for all this column for this particular row is your row key. Right? That's your ID. Yeah, if you see ideally, yeah, you can consider this to be a column also. Yeah, you can consider this to be a column. All right, so this would be a row key. All right. Okay. All right. Now coming to a point, Zookeeper. So the architecture of HBase which we have seen, there was always an Zookeeper involved there, which we have parked it for yesterday. Okay. Now let's see what is Zookeeper and why to use a Zookeeper. Now you can consider Zookeeper as your cluster coordination system. It's a framework. See, Zookeeper is not used by developers ideally. It is mostly an administrative tool. What Zookeeper does, your Zookeeper you can consider, it basically keeps your cluster in sync. It's a cluster synchronization tool. It's a cluster synchronization framework. Now when to use Zookeeper? So the best place where you can use a Zookeeper is when you have multiple processes, when you have a distributed architecture, so which Hadoop is definitely. In such places you can use Zookeeper. Right? Now why Zookeeper is used? So let's take an example of an HBase table. I have multiple clients writing to a single HBase table. Right? I have multiple people writing to a single HBase table. Now this multiple people can use the same row key also, right? So it should not, so if you consider any Java application or any application which is multi-threaded, multi-process application, there are cases of race conditions and deadlocks, right? So what is a deadlock? Let's say I have two threads. Okay, let's say I have a shared resource. You can imagine this to be an HBase table. All right. When I have multiple clients accessing this resource, okay, ideally this resource, when a single client is accessing, there is a lock on this resource, right? You have a concept of mutex. Okay, if you talk in terms of your OS, there's a concept of mutual locks, right? So when your client one access this, there is a lock on this table. When your client two, when your client one has finished accessing, it releases the lock, and your client two gets the lock. All right. When your client two finishes the access, finished writing or reading from this table, it will release the lock. Your client three will get the lock. Right? In such scenarios, there might be a possibility of deadlock. Okay. Now, what is deadlock? So you can say both the clients, you have a table which is already logged. Okay, and both the clients are waiting. Multiple clients are waiting to acquire that lock of that particular table. Okay, so here there can be a situation. These situations are called as race conditions. Right. So such race conditions can easily occur in any distributed framework. Right. Either it can be your, let's say, your HDFS file you're referring to, or an HBase table you're referring to. These deadlocks can occur at multiple places. Now, how to avoid these deadlocks? So Zookeeper is a tool which is used to avoid deadlock. It will sync your cluster. Okay, you can consider this to be your, if you are familiar with Java, you can consider this as your synchronization block when you're using multi-threading applications. So Minesh says he can't hear me. Is it true for everyone? Am I not audible? All right, all right. Okay. Okay. So you can consider, so if you're dealing with Java, right? So if you write a multi-threaded application and you have multiple threads changing a particular resource, you ideally use a synchronization block, right? That synchronization piece between your threads in a distributed environment is given by your Zookeeper. Okay, so this is a typical usage of where to use a Zookeeper. Now, this is only one use case where you can use a Zookeeper. There are other use cases also. Okay, so if you consider, so we have discussed this earlier also in case of HDFS architecture, when we discussed about your HDFS high availability, right? So remember, in HDFS high availability, you have two types of nodes, two name nodes. You have an active name node and you have a standby name node. Both sends their heartbeats to this Zookeeper. Okay, so what Zookeeper can be additionally used for? It can be used to store a particular state, okay, of your cluster. It can be used to store a state of your cluster. Let's say my name node 1 is active, and so Zookeeper will store the state that your name node 1 is active. Your name node 2, which is a standby name node, will keep on listening to the Zookeeper and check the status of your name node 1, which is your active name node. As soon as your name node goes down, okay, this will make an entry in the Zookeeper. Your Zookeeper will make an entry, a metadata entry, that your name node 1 is not working. So a standby name node, which is also continuously listening to your Zookeeper, this will understand by looking at the status which is logged into your Zookeeper that your name node is not working. Okay, that is the place when your standby will pick up. Your standby will become the active name node. So when you want to store a particular state of your application or a distributed environment, Zookeeper is the place where you should use. Okay, let's say you want to you are designing a distributed application. All right, my application is such that until my client one does whatever he is doing on your data, my client two should not do anything. Okay, your client two should get a mutual lock for that particular resource. Such things, okay, such state, okay, you can capture in your Zookeeper. So when your client one is doing something on your particular resource, you can log in Zookeeper the status of that particular client. When your client wants to access that particular resource, you can design your application in such a way that it always queries your Zookeeper first and check the status if that resource is available or not. If that resource is available, it will update your Zookeeper entry and make it unavailable. Basically make it, let's say it can change the state from ready to running, right? And then he can do whatever he needs to do on that resource. When your client one exits, it can change the status in your Zookeeper again. So basically what Zookeeper is doing, it is storing state of your application. It is storing state of your cluster. Why Zookeeper? Where Zookeeper can be used? Basically what Zookeeper can store. So you can consider Zookeeper to be a file system, very similar to your HDFS. Right? You can consider Zookeeper to be a file system, but it should not be used for storing data. The actual data, it should not be used for storing. It should be used for storing metadata. For example, my cluster state, or my name node state, or my application state. This is just a metadata, a single one-liner entry, right? That it's running, or it's ready, or it has failed. Those kind of states you can mention in your Zookeeper. So you should always use Zookeeper for storing your metadata. Okay. The best part, what advantage your Zookeeper is giving is, so it is highly available. Right, your Zookeeper is highly available. If you just deep dive, if you just zoom in Zookeeper is also multi-node cluster. Right, Zookeeper also works as master and slave. Right, if you just deep dive into Zookeeper architecture, your Zookeeper has something called as a Z master, that's a Zookeeper master, and you have multiple slaves. All right, you can consider this to be same like your HDFS. Zookeeper is a file system only. You can consider Zookeeper as your HDFS. The only difference between a Zookeeper and your HDFS is used to store real data, whereas Zookeeper is used to store metadata. Right? Small things. The reason why Zookeeper is used to store metadata is reading and writing through Zookeeper is extremely fast. It's extremely fast. Let's say I'm doing something here on my machine 1 in my cluster. Okay, and my machine 4 also needs to do the same thing. If my machine 1 updates my Zookeeper node that you cannot do this particular type of processing because I am already doing it, your node 4 will immediately get that status. Right? So it's a shared file system. So let's say I have a directory. Okay, now we are talking in terms of file system, right? Zookeeper is a file system. Let's say I have a directory XYZ in which I store my status. Okay, so if this particular node 1 updates the status, this node 4 will immediately get the latest status which is updated by this node 1. Okay, so this message transferring across all your nodes is very fast if you use a Zookeeper. Right? Getting a concept, what is Zookeeper? Okay, you can consider a Zookeeper to be a simple file system, similar to your HDFS. To avoid race conditions and deadlocks, to avoid management complexities. So if you want to manage use applications where I have multiple clients using some shared resources, with Zookeeper you can manage that very properly. Okay, like once my client 1 is accessing, put a lock, change the status, let my client 2 poll for the status. Those kind of complex algorithms you can do using Zookeeper. It is easy to use programming model. Okay, it can be used to apply reusable code and libraries in common use cases and to solve complex distributed algorithms. Okay, so Chaitanya says Zookeeper is only for HBase. No, Chaitanya. It is for your, it can be put into use for any of your distributed frameworks. It is used for by your HDFS also. Like if you talk about HDFS high availability, where you have name node and standby name node, that place also you require a zookeeper. Okay, so HBase also is one more application which have to use zookeeper. So Minesh says, is it an admin tool with a UI? Zookeeper, I think it does have a UI. Yeah, we usually access Zookeeper using a command line. Apache, I don't think Apache gives you a UI. Cloudera and other tools gives you a UI for Zookeeper also. So basically you can browse your metadata using the UI which is provided by your Cloudera or Hortonworks and Mapr. Okay, where you should use Zookeeper? Where you have multiple hosts, multiple processing, Java-based systems, there is a place where you should use a Zookeeper. Okay, so this is a Zookeeper. It basically maintains, it's just like your file system, right? It maintains your data in a hierarchical manner, just like your HDFS, just like any other file system. I can have I can have nested folders, nested hierarchy. Okay, that's a Zookeeper. Now, one thing to note, if you talk in terms of Zookeeper, so Minesh says, are there any similar tool like Zookeeper in the market? I'm not sure about this, Minesh. Zookeeper is mostly used in most of the places. So best thing is it is free to use, right? So most of the places Zookeeper is preferred. Okay. Now, if you're talking in terms of Zookeeper, every folder which you see here, okay, every folder which you see here, that is called as a Z node. Chaitanya says, is it from Apache? Yes, it's Apache Zookeeper. Right? It's open source, free to use. Okay. Additional thing, it is implemented in Java. Right? Internally, it is using your normal Java mutex, your semaphore and mutex, all those concepts. Okay. Now, every directory which you see here in Zookeeper, that is called as a Z node. Okay. So don't misunderstand with this term. When I say Z node, ideally this seems to be like a machine, right? I'm talking about node. This seems to be like a machine if you see in terms of the naming they have given. But Z node is not a machine. Okay, Z node is a name given to a folder. Z node is a folder in your Zookeeper. When you're talking in terms of machines, so you have a master machine and a client machine. Right? This entire Zookeeper cluster where you have multiple masters, multiple slaves, this is called as an Zookeeper ensemble. Okay, this is called as a Zookeeper ensemble. So ideally, if you're going in a distributed application, if you want to take full advantage of Zookeeper, you should have a Zookeeper ensemble which has multiple Zookeeper servers, multiple masters. Okay, it is suggested. Basically, it's just a probability statistic calculation. Okay, so there was a research like how many Zookeeper servers you should keep in an ensemble to make your Zookeeper highly available. According to probability, okay, according to probability, the number of Zookeeper servers inside an ensemble should always be in odd numbers. Okay, should always be in odd numbers. So you should either have 3 servers in an ensemble or 5 or 7 or 9. So your number of Zookeeper servers should always be in odd numbers. So this is a research on probability. So with odd numbers, what will happen is it is highly probable that your Zookeeper cluster is available. It's high availability probability condition. It's just keep in mind when you're using Zookeeper, always keep odd number of Zookeeper servers in your system. All right. And these Zookeeper servers, if I'm using 3 Zookeeper servers, this is called as a Zookeeper ensemble. If I use 5, it's called an ensemble. So ensemble is nothing but collection of Zookeeper servers. Okay. So this is what happens if you're using multiple multiple clients accessing a same resource. So which client should get a high priority? Okay, so your Zookeeper internally has a concept called as leader election. Okay, so Minesh says, but main file is stored on the master, right? Yeah, so Minesh, so if you have an ensemble, so when I say ensemble, you have multiple masters, multiple servers of Zookeeper. Okay, so your main file would be actually replicated across ensemble. So if I put something to my Zookeeper server 1, it would be automatically replicated to all your Zookeeper servers. Now, why this ensemble should be used? So this is basically when you have huge clusters which are shared across geographic location. Let's say I have a Hadoop cluster, which is, it's spawned across, let's say, India and US. It's the same cluster and residing at two different geographical locations. In such places where you should, so there would be a high network gap in between these two geographic locations, right? So such place is a typical scenario where you should use multiple Zookeeper servers in intermediate locations. Okay, for example, so let's say if this is your India location and this is your US location. Okay, I have a Hadoop cluster. I have some data nodes here, some data nodes here. Let's say I have my name node here. I have my standby name node here. Ultimately, it's the same cluster. Okay, but it's shared across geographical locations. All right. In such cases, if you're using a Zookeeper, connectivity between this India server and US server would have a lot of gap, right? Because the network bandwidth would be very less. So in such cases, you should use multiple Zookeeper servers in between these regions. Okay, so whatever, let's say India server puts in the first Zookeeper server, let's say I put some data here, Zookeeper servers will internally update and sync all of the Zookeeper servers. And that information is available to your US server. Right? This entire set of Zookeeper servers, this is called as a Zookeeper ensemble. Okay, Zookeeper ensemble. Getting it, Minesh? Okay. All right. Now this is just one terminology in your Zookeeper. So when multiple users are writing to a single resource, are trying to access a single resource, which user should get a high priority? So that is an inbuilt algorithm in Zookeeper called as leader election. Right. So we'll be discussing about this. So your Zookeeper, so this Z nodes which I talked about. So there are different types of Z nodes. One of them is sequential Z node. So it's not a part of a demo in this Edureka's syllabus, but I would be showing you a demo. Right. So you will understand what are the types of Z nodes. So there are three types of Z nodes available in Zookeeper. First, okay, so one is sequential Z node, one is a normal Z node, and one is ephemeral Z node. Okay, one is ephemeral Z node. Okay, so Minesh has a question. Okay, Rahul also has a question. HBase meta file will share to all Z server or one. Then Z server will transfer to Z server 2. Okay, yes, exactly, Rahul. This happens. Okay, so your HBase, what it does is, so all your region servers, all your HBase masters, they register to your Zookeeper. Okay, so I have multiple region servers, right, in my HBase cluster, and I can have multiple masters. Okay, at a time only one master can be active. So which one is active, which region server is active, so all of this metadata state information is maintained into your Zookeeper. All right, when I say maintain to your Zookeeper, so you can give it to any, so ideally how do you access Zookeeper? Through a Zookeeper client. So as per developer, if you want to browse it or if you want to put data into a Zookeeper, you will use a Zookeeper client and add data. Zookeeper will internally take care that which server it is connected to and how it will replicate. But ultimately, it will write to a single server and internally replicate across the ensemble. Okay, so Minesh has a question. Is it all configuration stored in any file like XML, like our big data config files? Yes, Minesh. Zookeeper has a config file called as zoo.cfg, zoo.config. Okay, in that you mention configurations about your Zookeeper ensemble and your slaves master, all of those things. Okay, now this Z nodes which I was talking about, so there is a normal Z node. Okay, normal Z node as in, so let's say I create a Z node. Let's say slash Hardeep. This is a Z node. Okay, now this Z nodes would be created by whom? By your applications. Okay, and why Z nodes would be created? So inside this Z node, I would be maintaining my status. Okay, so this Z nodes are created by your applications. Now there is a normal Z node. Now what this normal Z node is, let's say this is my application which created this Z node. When my application fails, or let's say completes, this Z node is still available. Okay, so this is also called as persisted Z node. Even if your application has completed processing, when your application exits, that Z node is still available in your Zookeeper. These are called as normal Z nodes or persisted Z nodes. Other types of Z node is, there is a Z node called as ephemeral Z node. Now what is an ephemeral Z node is, let's say I have one more application which is now creating an ephemeral Z node. Let's say location, let's say ABC. This is my Z node and it is storing some status. Now what is an ephemeral Z node is, as soon as this application exits, this Z node would be deleted. That is an ephemeral Z node. So this is basically as soon as and when as your client session is active, your Z node is active. As soon as the session exits, Z node is deleted. This is an ephemeral Z node. Okay, and the third type of Z node I have is a sequential Z node. Okay, is a sequential Z node. So what happens in sequential Z node is, whatever Z node you're creating, let's say ABC, whenever my application is creating a sequential Z node, a huge digit, a sequence number is generated and it is appended in your Z node name automatically. So it can be this. Ideally, it's a 9-digit number. And this particular application can create multiple Z nodes. So a typical use case where you should use sequential Z node is when your application is creating multiple Z nodes with the same name. So if you're using sequential, let's say this application creates 4 Z nodes. So I would be having same names, but my sequence would be different. So it would be 0002, 0003, 0004. What is an advantage of sequential Z node is, it is very simple to do a leader election. Okay, the Z node which has the least sequence number is given a highest priority. Okay, because it was least sequence number means this was created first. Okay, so if you talk in terms of multiple clients creating a same Z node, the Z node which has the least sequence number, that was the first client which came to your cluster. So if you talk about first come first serve basis, all right, so the Z node with the least sequence number becomes a leader, all right, and the remaining Z nodes follows that leader. So when I say follows means, so when your leader finishes writing, then your Z node 2 will get access. When your Z node 2 finishes writing, Z node 3 will get access. So ultimately the first action is done by your leader and the remaining Z nodes are followers to that leader. So it's a internal algorithm used in Zookeeper called as leader election. Okay, again this is used for your mutual exclusion, all right, to avoid deadlocks. This is an algorithm leader election used in Zookeeper. Okay, so Minesh says this must be consuming lots of disk space based on number of rows. No, Minesh, it does not consume a lot of disk space. That's an advantage of Zookeeper, right? Zookeeper should not be used for storing data. It is just storing metadata. Metadata is very small in size. It's ideally in bytes. Okay. If your data is very huge, you should never use HBase. The only reason HBase is used is reading and writing to HBase is very fast. Right? So if my application, if my client 1 writes it, my client 100 should get the current state, the current status like my client 1 is writing. Okay, so this information should be traversed across very fast. Right? So you should not use Zookeeper for putting a lot of data. You should not create huge number of Z nodes, huge number of status monitoring. You should not use Zookeeper for that. Okay, you should. So if you're using it for that, you should have a huge Zookeeper cluster. The ensemble should be huge with a lot of memory. So again, metadata, Zookeeper stores everything in memory, right, to make it fast. Okay, so, yeah, so yes, Minesh. Okay. Now where you should use Zookeeper? Where you want your application to be weight-free, simple, robust, good performance, tuned for read-dominant workloads, familiar models with and interfaces, need to be able to wait efficiently. These are the places where your application should use Zookeeper. Right? Now how Zookeeper is used with HBase. So as I mentioned, what your Zookeeper and HBase does is, as and when your region servers are started, every region server registers its Z node into your Zookeeper. And these Z nodes, which your region servers register in Zookeeper, are ephemeral. Right? These are ephemeral Z nodes. So as soon as let's say my region server is failing. So I have multiple region servers. Let's say I have 3 region servers. Every region server creates a Z node in your Zookeeper. All right, and this Z node is an ephemeral Z node. Now, what is the advantage of using this ephemeral Z node is, as soon as my region server 1 fails, okay, this is basically for tolerating for having your HBase to be fault tolerant. Okay, as soon as my region server 1 fails, this session got finished, right? Because it failed. So as soon as this fails, that ephemeral Z node is deleted. So at any point of time, your master knows how many region servers are active. All right. So this is for your master to know which region servers are active and to which region servers I can write data to. Okay. So this is how your HBase uses Z node, Zookeeper. Also your master. So I can have multiple master. I can have a master and a standby master. I'm talking about my Zookeeper master. Okay, so if I use multiple masters in Zookeeper, at any point of time, only one can be active. Okay, so masters also register in your Zookeeper. Again, ephemeral. Okay, so basically, so when your Zookeeper cluster is first started with multiple masters, they fight between the masters. Masters fight between each other to register themselves as master in your Zookeeper. The one which wins becomes the master. Okay, when I say wins, that means that particular machine was able to create a Z node in your Zookeeper. So one which is able to create a Z node in your Zookeeper becomes a master. The other one basically keeps on waiting, keeps on looping. Okay, basically this term is called as watch. It keeps on watching your master, right? As soon as your master fails, that particular Z node which your master had created, that Z node is deleted because it was an ephemeral Z node. So your standby master knows that this master has failed. Now a standby is able to register itself as a master. Okay, then so this is basically configure. So this is solving a situation, right? Your deadlock situation, your race condition. So this is helping you identify that only one master is active at a time, and as soon as that master fails, my other master can take up. Because this was using a watch, as soon as my master 1 failed, the Z node was deleted, and my master 2 can create a Z node now. My master 2 can become my active master. So this is how your zookeeper is used by your HBase. Right? Now, which master is active? So I can have multiple masters, right? So this is same in your HDFS also when I have a standby configuration. If I just talk about masters, let's say I have master and these two are my standby master. You can consider this to be an HBase masters also, your HDFS masters also. Okay, both of these areas uses zookeeper. Right? So I can have, so all the masters register themselves in your zookeeper. So this can be your HBase system also, or it can be your HDFS also. Okay. Now I as a client, I want to connect to my HDFS or HBase. If I want to connect, how will I know which machine to connect to? How will I know which is the currently active master? It can happen, right? If I connect to this machine, basically I'm connecting using an IP address, right? If this machine fails, the client will get a socket exception, connection timeout exception, because this machine has failed. But when this machine has failed, with this zookeeper thing, this machine has become the active master now. But my client does not know it, right? According to my client, I have two standby masters. Which one is currently active? My client will not know. So what a client will do, your client will first try to this machine. If it gets a connection, well and good. If it does not get a connection, it will try this machine. Okay, now in my distributed environment, I can have n number of standbys, n number of standby masters. It's very difficult for me to again and again log into my application, change the IP address of my masters. Correct? If I'm connecting to this machine, my IP address is different. This machine IP address is changed. This machine IP address is changed. So as soon as a master fails, your entire application will fail because it'll start getting connection timeout exceptions. Okay, such cases can also be handled using zookeeper. So what happens in this case is, so if you have multiple masters registering to your zookeeper, your clients does not connect to a single master, it connects to your zookeeper. Right, your clients, it connects to your zookeeper. Yeah, so Chaitanya says, so what admin will do will be done by a zookeeper. Ideally, no. So what your admins will do, Chaitanya, your admin, so if your machine has failed, your admin will fix that machine. So zookeeper is not fixing it. Okay, zookeeper is just redirecting your client to your currently active master. You can consider zookeeper as a load balancer. Okay, you can consider zookeeper as a load balancer. So what happens with zookeeper is, in such scenario is, your client does not connect to master directly, it connects to your zookeeper. Your zookeeper will tell your client which is the currently active master, and automatically it would be redirected. So for your clients, it just needs to connect to one IP address, and that IP address is the address of your zookeeper ensemble. Internally, it would be redirected to the active. Let's say this one is active, so internally this is redirected to this machine. Let's say this fails, now this is active. Internally, my client would be redirected automatically to this active name node or active master. Okay, so this is how your zookeeper is helpful, and the same thing, your zookeeper is used in HBase. Zookeeper, so what your zookeeper is doing with HBase is, all your region servers, all your masters are registering with zookeeper using a Z node. Another thing which a zookeeper stores is, your zookeeper stores the location of your meta table, your meta and root table. The location of these are catalog tables in your zookeeper, in your HBase, right? Dot meta dot and hyphen root hyphen. The location of these tables is also stored by a zookeeper. Okay, so a client, when it connects to zookeeper, Zookeeper will very simply redirect your client to the root and meta tables, and from there it can connect to your region servers. Right? So without Zookeeper, you cannot use HBase. Okay, the first prerequisite for using Zookeeper, using HBase is you should have Zookeeper installed. Again, if you don't install Zookeeper, HBase will internally install it. Okay, the HBase, if you install HBase, HBase will automatically first install Zookeeper and then install HBase. Right? Chaitanya says, even with single machine, yes, Chaitanya, even with single machine, Zookeeper is a prerequisite for HBase. The Zookeeper, the HBase API is written in such a way that it can connect only through Zookeeper. Okay, so Minesh says, does it work on MongoDB or DynamoDB? Yes, Minesh, you can use Zookeeper to work with any distributed cluster, any distributed where you have multiple masters, multiple slaves. You can Zookeeper is a best fit there. Okay, so Rahul says Zookeeper also has a standby Zookeeper. A good question, Rahul. See, Zookeeper itself. So the I can reframe the question. Okay. So when I say my master is failing, my Zookeeper is handling that. What happens if my Zookeeper fails? Okay. So this condition will never happen. It's a very rare condition, right? That's why I talk about Zookeeper ensemble, where you have multiple Zookeeper servers active. Right? So Zookeeper itself is a very extremely highly available framework. Zookeeper will never fail. So even if some of the machines are failing in Zookeeper, your admins should be going and fixing that and adding them back to your Zookeeper ensemble. So yes, of course, monitoring would be required, manual monitoring that would be done by your administrators. That's why you should have more number of machines in your Zookeeper ensemble. The more you have, less chances of your entire Zookeeper going down. Okay. So these are all the Z nodes which your Zookeeper creates. Sorry, your HBase creates in Zookeeper. It creates a Z node for master, for region server, for root table, and while shutting down, which one is active, which one is not. All right. Okay. Now the latest version of HBase would be 3.3.0. So what's there in HBase 3.3.0 is just some latest features, right? Improved logging, improved debugging, improved documentation, improved performance. Okay, queue implementations. Okay, session timeout, min max bounds. These would be added in your HBase. I think 3.3.0 is already available. All right. So in the previous, see, HBase will mature because HBase is still not very mature. It came up around 2012, right? It's not in 2010. Sorry, it's around just 7 years old. Okay, so it will mature slowly. So initially in the previous versions of HBase, there was no concept of a wall file. This was added in the latest versions. Okay, initially this wall file, memstore, block cache, nothing was there. Okay, so initially HBase, though it was said HBase is real time, but HBase was still slow. But with addition of all these latest concepts like a wall file, memstore, and all of these, HBase has become really fast. So let's try some hands-on with HBase. So this was the last slide. So let's try some hands-on with HBase. So HBase is already available in your Edureka VM. I was not able to find HBase in the Edureka cloud cluster which they have provided. Right? So it was there in the VM. This is working a bit slow. started. Okay. So I'm logging to the root user. I'll just check is my Hadoop working or not. Yeah, so Hadoop is working, but HBase is not working. Right. So let me start HBase. Let me find where is HBase. I think it's there inside your USR lib HBase. Yes. Okay. So HBase. Yeah. So if you just look at HBase installation, so it's very similar to your Hadoop installation. You have a bin folder, you have a conf folder, sbin folder, all of these. Sorry, sbin is not there. So if you go to conf folder, this is all your configurations where you do. Remember in Hadoop you have HDFS site, MapRed site, YARN site, core site. So HBase has HBase site. Right? In terms of Hive also, Hive has a Hive site. So this is an XML file very similar to your Hadoop where you can configure your HBase. Okay, so it's already configured. I'll go to my bin. If you see the scripts here, I have scripts to start and stop my HBase. I have start hbase.sh. So I'll use this script. So it will start two things. Right? It will start HBase also. It will start Zookeeper also. And in HBase, it will start an HMaster and a region server. And in Zookeeper, it starts something called as quorum. I don't remember the daemon name. It's something with quorum, Quorum. It started. Let's confirm using a JPS. See, so I have H region server. H quorum peer is your Zookeeper. Right? I have H master. So I have three daemons. H master is your HBase master. H region server is your region server. H quorum peer is for your Zookeeper. And this remaining are my HDFS, data node, name node, and my YARN, node manager, resource manager. So I enter into HBase shell. So in the same bin folder, you have your HBase command. Right? So let me first enter into Zookeeper. So if I just say HBase and enter, these are all the options which your HBase gives you. So this is Zookeeper CLI. Okay. So I'll first enter into Zookeeper CLI, HBase ZK CLI. So it is also a file system. So there are commands like your normal file system only. Okay, there's a ls command, get the status, set the status. Such kind of commands are there in Zookeeper. All right, it is connected. Right, Zookeeper is connected. So if I do a ls in Zookeeper, okay, so it gives me, okay, right. So ls, it's a wrong command. Ls, I have to give a path. Okay, so if you see, what are these? I have HBase and Zookeeper. These are Z nodes. So in this root location, so this root, this slash location is your root location. So this is also a Z node. So in my root location, I have two Z nodes. If I browse, so it's, you can consider this too, but normal directory structure. Okay, so if I just look at it in HBase, so see, these are all the Z nodes which are created in your HBase. We have a Z node meta region server, backup master, table, draining, table lock, running, master, namespace, HBase ID. These are all your HBase Z nodes. Most of the information is stored in your replication Z node. So if I do a ls on replication Z node, so this is my RS. RS stands for your region server Z node. Right? See, this is only a single entry. So what this entry says, I have one active region server, which is running at localhost. The port is 60020, and this is the timestamp when this started. when I will stop HBase, this node will automatically get deleted because it's an ephemeral node. Okay. See, this is not a part of the syllabus, but let me give you a demo of ephemeral node. Okay, clear is not there. Okay. Let me give you a demo of ephemeral node. So what I do is, let me create a Z node. It's not a part of HBase also, it's just part of Zookeeper. Let me create a Z node. So let's say I create a Z node. Okay. I create an ephemeral Z node. Let me just recheck the command. So we don't use Zookeeper a lot. I mean, I don't have any much of practice on Zookeeper. So let me just search for the command. This is the logo for Zookeeper. Oh, so if I create a Z node, I need to give some status also to it. What I will do is I'll open one more session of Zookeeper. Okay, in one more session, I open two terminals with Zookeeper. It's my user lib hbase bin, and I say hbase zkcli. Okay, so I have two Zookeeper sessions active. You can consider this to be two clients connected to your Zookeeper. Okay, now what I will do is I will create a Z node from my session one. I'll create a normal Z node. So I say create /Hardeep, and I will set the status as let's say status is running. So it created. If I do a ls on slash, see this Hardeep is created. If I go to my second session, if I do a ls on slash, see Hardeep is available here also. So if my client one is creating anything, my client two and ultimately all my clients have this information. So this information is passed on very quickly. Zookeeper is very fast in that. Okay, if I want to get what is the status, so I say get, I think this is the syntax. Yeah, so if I say get, it gave me the status. Right, some other metadata fields also. Right? It's an ephemeral node or not, what was the version, create time, max time, so it gives you other information also. Right? So there's some actual status. If I say get on a particular node, Z node, it gives me the status. This status was set in my different node. I can change the status from here. Let's say I change the status of this Z node to a different status. Did it work? I think it has been changed. Okay, yeah, I think it's been changed. Let me get the status from my previous session. So I say get C. So in any of the sessions, if I'm making any update to my Z node, it is passed on to all your clients very quickly. Okay. Now what I will do is, from the machine, from the client which I've created this node, I exit that client. I exit my Zookeeper client. From here, I had created my Z node. Okay. So if I exit my client, if I look at my second client, if I do a ls again, that Z node has not been deleted, it's still available. So this is a persisted, a normal Z node. It is persisted. Now let's take an example of ephemeral Z node. Okay, so I will again enter into HBase Zookeeper CLI. You're getting it right? I mean, is it going like a bounce or something? You're getting the demo? Everyone, you're getting the demo? Yeah. So I would say as developers, you would not really be using Zookeeper a lot. Okay, it's totally administrative. Okay, so what I do is from my session 1, I create an ephemeral Z node now. So I say create minus E is ephemeral. I create a Z node, let's say XYZ with the status, let's say on. So it is created, right? If I look at my second client, this is my second client. I do a ls. See, XYZ is available here. The beauty of ephemeral Z node is if I exit my session from here, I pressed a Control C, and if I do a ls now, okay, so Control C is not basically exit. Okay, I should exit it gracefully. Okay, so now it know that it's not available. So I pressed a Control C, that's why I did not stop gracefully. Okay, but when I re-entered it, it got deleted because session was still active. Okay, so if I now do ls, that XYZ is now deleted. These are ephemeral Z nodes. Right? If I try to create a Z node with the same name, it gives me an error. So if I say create, let's say it says node already exists. Okay, but this will not happen if I create a sequential Z node. So I create a sequential Z node with a create minus S. I'll say, let's say ABC with a status. So it has created C. It has created a sequence 00005. If I say create again, it has created 6. So this is a sequential Z node. Right? This would be available to my other clients also. So sequential Z nodes by default are persistent. Right? I can create an ephemeral sequential Z node also. How to do that? So I can say minus S minus E. This will create a sequential node which is also ephemeral. Okay, so this was about Zookeeper. So now let's go to my HBase. So I say HBase shell. Yeah, so Chaitanya says in order to access HBase client, always create Z node first. Yes, Chaitanya. Okay, in order to create HBase client, you always have to create a Z node, but you are not creating it. HBase will automatically create. Okay, that was just a demo I showed you how to access Zookeeper. but ideally you will never enter into a Zookeeper shell. You will just install HBase, start your HBase shell, and you're good to go. HBase will internally use Zookeeper and register their nodes. This was just a demo which I showed how to access and create nodes. All right, now I'm into HBase shell. Now the syntax in HBase is very different. It is no SQL, right? So if I want to create a table, the syntax for that is I say create. In single quotes, I give my table name. So let's say I give my table name as employee. Or let's say I give an entire name, employee. Then you have to give a comma, and in single quotes again, you have to specify the column family. Let's say my column family is EMP. So remember, whenever you're creating an HBase table, the first thing you're doing is you're specifying the column family. Without that, you cannot create an HBase table. Okay, so this is a syntax to create. Now, if you notice, I am not defining any data type. I'm not defining any schema, nothing. I'm just defining the table name and column family. That's it. This is my command. It's still running. Okay, table created. Now, how to check a typical command, how to check tables in normal database? You say show tables, right? But here there is no command like show tables. There is a command called as list. So list will show you all the tables. So list displayed me that I have a table employee. Now to how to insert data into this table. So see, consider, so ultimately it's a map, correct? It's a hash map, Java hash map. How to insert and get data from a Java hash map? What is the methods for that? To insert data, the method is put, correct? And to fetch data, the method is get. Same commands are converted to HBase commands. So if I want to insert data into this table, so I will use the command put. Now how to insert? So put, first argument I'll give, what is my table? Okay. Then I will specify my column. Right? How to specify a column? Let's say I want to add a column name, employee name. So I'll say column family, which is EMP, colon, my column name, which is, let's say, EMP name. Okay. Then you specify the actual value. So let's say the name is Hardeep. This is how you insert to an HBase table. Am I missing anything? What do you think? Am I missing anything in this? I'm missing one thing. Let me tell you. I'm missing one thing. What one thing I'm missing? Exactly. Rahul says ID. Minesh says timestamp. Timestamp, no Minesh. I don't specify timestamp. It is auto-generated. Okay. I did not specify the row ID. Okay. Remember the row key. So the row key is the first thing which you specify. Okay. The row key is, let's say, 1. Okay. So there is no spaces in between. There is a comma. So this has inserted a row. Okay. Now, see, if I just reiterate the command, I have to say put table name, then give a comma. You have to specify the row ID, comma, specify the column which you need to add. How do you specify a column? Column family, column the column name, and then the actual value for this particular column. Now, if I want to check this data has been inserted or not, normally I do a select star. So there is no select star syntax here. The syntax here is scan. So I scan this table employee. Now see what it shows me. It shows me the row with the ID 1. It shows me the column, which is EMP colon EMP name. It showed me one additional thing, which is timestamp. This is auto-generated by your HBase. And then the actual value. If I insert the same data again, it has inserted. Now what do you think? How many rows are there in my table? 1 or 2? Okay, so Chaitanya says you haven't mentioned row while creating a table. So while creating table, I don't mention a row, right? I just mention the column family, that's it. While inserting, I mentioned, so every insert statement is inserting one row. All right, clear, Chaitanya? Okay, so how many columns, how many rows would be there now? So Minesh says 2, Rahul says 1. The right answer is 1. Minesh, why not 2? The reason is I have used the same row ID, same key. So what it has done is it has actually gone and updated my data. How will I verify that? If I do a scan, if you check, my timestamp has changed. So if you see the last 3, 630, and here it is 072. So my timestamp has changed, but it is only still one row. Okay, if I change the value also while putting it, let's say Hardeep underscore 1, but I don't change the row ID, it is still one row. My value has been updated, see. And timestamp is also changed, but it is still one row. Why? Because I am using a same row ID. So if you use the same row ID, it will update the existing data. Okay, and what will happen to the previous data? It will still be there with the previous version. Now let's say I insert multiple rows now. So I insert row ID 2, row ID 3, row ID say 5. Now if I do a scan, I will see 4 rows, 1, 2, 3, and 5. Okay. Now let's check sorting. So let me insert one more row with employee ID 100. Okay. What do you think? What should be the sort order? 1, 2, 3, 5, 100 or 1, 100, 2, 3, 5? Yeah. So Rahul says, Chaitanya also says 100, 2, 3, 5. That's exact. Right? So let me scan it. See. So it has automatically sorted. So it is not following your insertion order. Whatever data you insert, it will sort and store. Right? Yeah. So Abhilash says, is it normal that the message is 0 rows after every insert? Yes, Abhilash, it is normal. Okay. Basically, every insert, every command returns you this message. Some rows in how many seconds. So put basically is not, you're not fetching anything. That's why it is giving 0 rows. Yeah, so Rahul says, if we have data in the file like CSV, do we need to convert in this format? Ideally, no. You will not be using, you will not be converting into this format. You can use a normal Java API or a scoop command to load that CSV file into your HBase table. You can do bulk, you can use bulk loading techniques. So if my CSV contains 1000 rows, I won't use 1000 insert queries, right? That would be very time consuming. So in such cases, you would be using the bulk loading techniques. Okay. Now how to fetch data from HBase? So HBase has very limited commands: get, put, scan. All right, it's very limited. There is no SQL. Okay, so let's say I want to get a particular data. So I say get, I get the table name, and I give the ID. It will give me the value. So see how fast it ran. It's a single node cluster, so still it is so fast. Imagine if I have a very huge cluster, it will be very fast. So it retrieves the employee name for this particular row ID, basically all the columns for this row ID with the value and version. If I keep on fetching, my time would reduce and reduce. Okay, so you'll not get a clear thing. But see, first it took 1770.1770, then it happened in 0.1220. It's basically because of caching. Okay, you will see different numbers. So now it took a lot of time. But in actual case, if my block cache is huge, this retrieval would be very fast. Okay, so Rahul says any tool available to store data in HBase from web service? Yes, Rahul. HBase itself comes with a tool which you can expose the HBase service as a web service. Okay, so instead of using the shell, you can post data to your web service. HBase will automatically enter it into database. It is there. HBase comes pre-built, pre-packaged with that service. It is basically a REST API. Okay, a RESTful API. Okay, now how will I drop table? So for dropping a table, the command is drop, but you cannot drop a table. So for dropping a table, there is something you should first disable the table. So there's a fixed thing in HBase. So if I try to drop it, it'll give me an error. It says error table employee is enabled. Disable it first. Okay, so I have to say disable. Disable basically makes your table read only. Okay, so I'll disable the table and I will then drop the table. And if I do a list, no tables are there. Okay, so this is so usage wise, it is simple because there are not very many there are not many commands to use HBase. Very limited set of commands. That's why it's simple. Okay, but you cannot imagine using your normal SQL on your HBase, right? I cannot do a select star. I cannot do count star is there. I mean, I can do a count of how many rows are there. That is possible. But I cannot use some functions like upper, lower, min, max. Those kind of things you cannot do in HBase. Through Java API, yes, you would be able to design that, but still you should not do it. HBase is just meant for real-time read writes. Okay, HBase should not be used for analyzing the entire set of data. If that is the case, don't use HBase. Right? Use your MapReduce. Okay, if you want to process your entire set of data, use MapReduce, never use HBase. HBase would perform very badly if you are trying to process the entire data. Right? Okay, so let's do one thing. So let's take a break now, and after the break, we will start with Spark. Right? After break, we will start with Spark. So let's take a 10 minutes break. Okay, this is a break, and this is not, it's not a logical break, it's an actual break. So if you have any questions, you can still post it. I would answer those when I come from the break. So I'll just set up a timer for 10 minutes. Right? And after this, we'll start with Spark. All right. Okay, see you guys in 10 minutes. All right, guys. So I hope everyone is back. Okay, so Rahul has a question. Uh, HBase service is to retrieve data or store data from another web service. Suppose I have web service and giving data. I want to store that data to HBase. Any direct way? Yes, Rahul. I mean, HBase, you can expose HBase services using a web service. Now you can expose it for both the ways, for reading also, for writing also, right? Like one of the projects which I mean my colleagues are working on, we are using HBase. So we have exposed a web service. We get a JSON file from the client. Okay. So we read that file. We give it to the HBase web service to store that data into your HBase. Right. Once your client wants a data, so we have designed my row key. Okay. So it's based on the document ID and whatnot fields we have. Once your client wants to read the data back, it again just clicks a button. The application triggers a web service REST call to my HBase, which fetches the data and retrieves the back. So it can used for both the ways, for storing also and for retrieving also. Okay, Chaitanya says, can you show the H file of employee? Okay, let me, actually I haven't seen it myself. I think it's a local mode. Let me just check it's available or not. So I'm not sure how this HBase is configured, what locations it is using. So let me try. Okay, so Jiten, I don't think this HBase which we have installed, it is configured for Hadoop. It is running in local mode, right? It is not running with Hadoop, right? So it is not storing anything to HDFS. So my H files are all local. So if you configure HBase to work with Hadoop, your H files would be available under a directory /HBase in your HDFS, right? So this directory is not created here. That's why H files you won't be able to see. All right. So let's get started with Spark. Right? So I don't require this VM anymore. I'll just close it. All right. Now, this Spark is a very hot topic in the industry right now. What is this Spark? What special it is doing which your other tools are not able to do? Okay. So let me describe you Spark in brief, in a nutshell, what is Spark, and then we will switch on to the details. In very simple language, you can consider Spark to be an in-memory processing tool, right? It is an in-memory processing tool. Like, so this is different from your MapReduce, right? Your MapReduce, what it does, your MapReduce processes your data. So let's say I have a file which contains multiple lines. What your MapReduce will do, it will process each and every line, basically your entire file line by line. For every line it is reading, it is doing a disk IO. Now disk IOs, right? These are very expensive. Disk IOs are very, it takes a lot of time to disk IO. All right. So this is the reason your MapReduce works slow, because if I'm dealing with very huge file, Basically, it will be having multiple large number of blocks. A 128 MB block also contains millions of lines. So 128 MB for a normal text file, that's a very huge number. Like even if you have a text file which contains, let's say, around 1 million lines, that would hardly take the file size to around 5 to 6 MB. Right? Imagine 128 MB, the file size would be very huge. Now for every line in that block, in that file, your MapReduce is doing a disk IO. Imagine, remember my map method of your MapReduce? It runs once per line. So for every line, it does a disk IO. That's why MapReduce, it's called as a sequential data access. Now, on the other hand, how does your Spark solves this problem? What your Spark will do, so if I have the same file, your Spark will suck this entire file into your RAM, into your memory. Right? What my MapReduce was doing, processing file line by line, it will do the same thing. But the difference is MapReduce was doing it per line per se. But my Spark will do it per line on my memory. So it will, this one line which your MapReduce is reading from disk, your Spark will have that line already available in your memory. So my processing power becomes very fast. Okay, that's the major difference between your disk processing tools like your MapReduce and your memory processing tools like your Impala and Spark. Okay, so Spark, what it does, it takes the entire data into the memory and processes your data in memory itself. Yeah, so Chaitanya says it requires robust hardware. Yes, it does. So if you go to the pure basic definition of Hadoop, an advantage of Hadoop was Hadoop can work with commodity hardware, correct? Commodity means commonly available hardware. But if you're talking about memory tools, okay, now why these memory tools are required? This is basically to speed up the processing. Like whatever time my Hive or MapReduce takes, my in-memory processing tools would be very fast. So if you want speed, that means you want memory processing. If you want memory processing, your RAM is not, it's not cheap, it's very expensive. All right. So if you want to use any memory processing tools, that means you have to invest a lot in your memory, in your hardware. Okay. So with these memory processing tools, though you are getting an advantage of speed, but it has shifted the core definition of Hadoop that Hadoop can work on commodity hardware. Right? With tools like Spark, Impala, Tez, right? These tools it cannot work on commodity hardware. It requires hell lot of memory. All right. But the only advantage you're getting with in-memory tools is speed. Right? The processing time would be very fast. Okay, so there are multiple tools in market which can do in-memory processing. You have Impala, you have Apache Tez, and then you have Spark. All right. Okay, so Minesh has a question. Also, does it need Hadoop clustering? Yes, Minesh, it does need. Right. So there are different working modes in which you can use Spark. Okay, so you can use it with Hadoop cluster also. Right. So Hadoop for Spark, I can say it is not mandatory. Okay, if you want to use Spark, it is not mandatory to install Hadoop. You can run Spark on local mode also on a single machine, or you can run Spark on multiple nodes without Hadoop also. Both are possible. Okay, but it integrates with Hadoop. Right? Your Spark can integrate with Hadoop. That's why a Spark is a Hadoop ecosystem project. Okay. All right. Now there are multiple tools available in market, right? Now, what the Spark does, which your normal MapReduce is not able to do. The first thing is memory processing. Okay. The first thing, it is able to give you speed. Right. But definitely at the cost of memory. Right. You have to spend more money, more rates on your memory. Okay. All right. Now with this Spark was it's relative a new tool, right? Spark is not very old. It's getting developed since the vision is very old. Okay, it was getting developed since a lot of time, but Spark became stable recently, right? It's I guess not even a year that Spark is stable, right? But still, Spark has lots and lots of issues, right? So I would say around 5 to 6 months back, no one was using Spark in real production. Okay, Spark was not production ready. Okay, now a few companies have shifted their normal processing to Spark, but yeah, so I also have an experience working on Spark. I would say working on Spark is for now very difficult. Okay, Spark, there are lots of things which you need to tune if you need speed. It's not like that I use Spark and my entire query will run within milliseconds or within seconds, right? That's not a case. For every query, a lot of tuning is required. Okay, this is the reason most of the projects which are working on Spark in production are struggling big time. Okay, because there are lots of levers in Spark which you have to configure. And Spark, yeah, it is developed by the open source community. So Spark was basically developed by a company called as Databricks, right? Then it went to Apache. So now it is open source, right? But though it is open source, there are lots of bugs in Spark. It is, I would say, it is too early to use Spark in production for now. Okay, we ourselves are struggling on Spark. I mean, so what we did is we converted. So everything was in our case was running on Impala, right? We shifted everything from Impala because Impala was an expensive tool. It is not open source. We shifted everything from Impala to Spark, right? And we are facing so many difficulties that we are actually making our nights dark, right? We're sitting in office for a lot of time to just configure and make Spark run. And issues in Spark is basically the documentation which is there in Spark. It is not enough. You require more documentation. It's very limited documentation which is available. Okay, so Minesh says, but we see a lot of requirements for Spark and Scala compared to Hive and Pick. Yeah, Minesh, actually the thing is, so Spark has become a very hot topic in market. So even no one knows Spark, but still they want Spark developers in their company because everyone in this phase is basically they are learning Spark. Okay, so companies, organizations are looking out for people who at least know basics of Spark so that they can start working on it. Though not optimized, but they can start working on it because this is the next big thing in market, Spark, right? I'll say in the next 2 to 3 years, MapReduce would be gone full time, right? It would be only Spark which would be available in market. Okay, you can say it is the next generation of MapReduce. It's a next generation of distributed processing. Okay, but now, yeah, it is very hard to use Spark. Okay, so I'm not making you afraid of using Spark. Using wise, it's simple, but tuning wise, it is difficult. Right? Okay, so it is an in-memory cluster processing platform. All right, so Minesh says, but still it is for structured data, right? No, Minesh, it is for all types of data. Just like MapReduce, structured, unstructured, semi-structured, all type of data. In fact, it has given more functionalities than our MapReduce. For example, Spark has libraries to work with machine learning kind of things, right? Like your artificial intelligence kind of things. Chaitanya says, again for big data? Yes, again for big data. Okay, Spark is for big data, right? Okay, so I was talking about machine learning libraries. Now, what is machine learning? It's just an algorithm. For example, I'll just give you an example. Uh, if you take an example of your Gmail or Yahoo Mail, if you notice some of your mails automatically go in the spam box. Now, how it automatically goes? Do you mark those mails as spam? No. It's your Yahoo mail engine or your Google mail engine which automatically identifies some mails and puts them in the spam box. Right? Now, how they are able to identify this? This is basically machine learning. Your tool, your machine itself is learning that such trends in your mail, if it is there, then it is spam. This machine learning libraries is also available in MapReduce also. Okay, in MapReduce there is a library called as Mahout. Just to name it, there's a library called as Mahout. So what is Mahout? Is basically a machine learning library which works with MapReduce. What Spark did? Spark created similar kind of a library, but the only difference is Mahout works on MapReduce using disk IOs, very slow. Spark's machine learning runs on memory, in memory, very fast. Right? Spark has created some more algorithms. For example, if you talk about graph database, okay, if now how you can consider a graph database? Like if you just talk about a social network, okay, if I talk about, let's say, Facebook, so I said this is me, okay, this is me. Now let's say I have two friends. This first friend has three more friends. Okay, this has two more friends. Okay, let's say one friend is common. Now this friend has multiple friends. Every friend has multiple friends. Some has common friends. Now what is this? This is a graph structure. Right? Now if you talk about Facebook or LinkedIn or Twitter, where you get recommendations that friends you may know or connections you may know. So how it does that basically? So if you have your immediate friends, the friends of your friends are recommended to you. Correct? Now how this is possible? This is possible if you try to process such graphical kind of system. To store such type of data, there are graph database also available. Okay, so if you talk about NoSQL also, there is a category NoSQL called as graph database. The most famous graph database is Neo4j. Spark, it gives you an additional functionality to process this graph database, which MapReduce never had. Okay, you can do processing on this graph database using Spark, which would be in memory and fast. Right? So Spark is giving you lots of things. Right? So yeah, so if you see Spark's versioning thing, right? So from Spark's initial version till now, the latest version of Spark is around 2.2 something, 2.2.0. If you see the versions, there are lots of things added in every version. So basically Spark team, what they did is they are adding lots of things inside a single package, but till now they haven't worked very much on optimizing each and everything. So this will come over time. Okay, so if you talk about Spark version 1, so latest one was 1.6. From 1.6, Spark went to 2.0. Okay, so if you compare 1.6 and 2.0, the Spark team says Spark has become around 10 to 20 times faster as compared to 1.6 and 2.0. It has become more faster. So over the period of time when next releases would be there in Spark would definitely get, the only tool which will be used by each and every company. Right? That's why companies are looking for Spark developers. Okay. Now what is Spark? It is basically an in-memory cluster computing platform. So it processes all your data in memory. It runs lightning fast by performing computations in memory. So whatever happens in memory, these computations are very fast. Now one thing, where you should use Spark. So Spark should be used in such cases where you have iterative algorithms. Okay, let's say for iterative as in, let's say you have one data set, and from this data set, let's say it's a 10 GB data set. From this data set, you are processing and creating multiple outputs. All right, from a single data, you are again and again processing it, creating multiple different types of outputs. Such types of processing is iterative. Okay, so what Spark does is this entire file, which is referred multiple times, you can cache this file in memory. Once you cache this file and once you refer a cached version of this file, it will never go to the disk. So your performance of your queries, if it's an iterative kind of an algorithm, Spark is best suited. Okay, if it was not Spark, if it was MapReduce, then for every job, it will run a MapReduce job. For every processing, it will run a MapReduce job. Means this job one will read the file from disk. This one will read the file from disk. Every job will read the file from disk. So there is no performance gain here. But if you talk about Spark, Spark is capable to suck this entire data and keep it in memory, do as many computations you want on that specific data set, and then you can uncache. You can clear the memory. Yes. So Minesh says, is Impala works similar way? Yes. Impala also works in similar way. The difference in Impala and Spark is, so Impala will automatically cache. In Spark, you have to explicitly cache it. Okay. If you talk in terms of Impala and Spark, I would say there is no other tool like Impala which is fast. Impala is extremely fast. It is extremely stable. Okay. If you talk about Spark, Spark cannot compete with Impala. Okay. So we had actually done a lot of POC. So we had started using Spark. It's almost a year we started using Spark. So we didn't use Spark in any project directly. We did a lot of POCs, lots of research on Spark, lots of comparison between Spark, between Hive, between Impala. Okay, we did a lot of POCs. The final output we gained from these POCs is, let's say I have a query. So what we did, so there are multiple things involved, right? There is size of data, there is number of tables involved in a join, there is file format for each table, like it's a text file, a compressed file, or a paragraph file, sequence file. There are lots of things involved. So for every dimension, we did some use cases, we did some POCs, right? We found out that, let's say for a specific query, Hive is taking 5 minutes, Spark will take around 2.5 minutes. You can say 50%. Right? But if you compare with Impala, Impala takes 10 seconds. Impala is extremely fast. No comparison till now with Impala. And Impala is very stable. For Impala, if you compare query with Impala and Spark, for every query you need to tune your cluster. Okay, you need to play with some properties if you're using Spark. With Impala, there is nothing. Impala itself is very intelligent to identify what things need to be set, what things need not to be set. It will automatically run your query without specifying, without tuning your query. It will still run. It will not fail. But Spark, a lot of time your Spark goes out of memory. Yeah, so Mine says, but Impala works only with Cloudera. Yes, that's the only thing with Impala. It works only with Cloudera. Okay, Spark can work with anything, any cluster. Apache, Cloudera, Hortonworks, MapR, anything. Okay. It is extension of one of the most widely used popular framework, MapReduce. So it is an extension of MapReduce. So similar kind of thing which you have in MapReduce, like you have a mapper face, reducer face, every map runs on a input split. It is much similar to that. It's the next generation of that, you can say. It is not very similar, it is the next generation. Right? It is inspired from MapReduce. It's a unified stack, provides rich set of tools like Spark SQL, Spark Streaming, GraphX, and machine learning library, mlib. Okay, Spark. Now one thing with Spark, Spark does not mandatorily requires Linux. Spark can work with Windows also. So if you want speed with a Windows machine also for processing, you can use Spark in Windows. But definitely you cannot integrate Spark with Hadoop if you're using a Windows system. Okay. Now, why Apache Spark? What Apache Spark is giving you? So it is giving you ability to run faster analytics of large data in memory across cluster of machines. Right? It is a unified stack, makes easy adaptation of new components along with existing components. Right? So your existing components, for example, your Hive, right? It can work with Spark. So remember I told you with the latest version of Hive, there is a property in Hive in which you can change the execution engine of Hive. By default, Hive's execution engine is MapReduce. Like whatever query you give to Hive, it converts to MapReduce. But now you can change the Hive's execution engine to Spark also. There is just a property to set, and after that, all your Hive queries will now run in Spark. So that is basically termed as Hive on Spark. Yeah, so Manish says they share the metastore. Yes, Manish, they share the metastore. All right. So one of the most powerful feature of Spark is it can easily integrate with Hadoop cluster. Right? That's a very powerful feature. So if we on a Hadoop cluster, if you want to do memory processing, so I can simply integrate Spark with Hadoop. So basically, Spark can work with different platforms. So if you say Spark itself is a platform, right? Spark itself is a platform. Now, when I say platform, so you can relate this with Yarn. So Yarn is also a platform, right? It's a cluster management platform. Similarly, Spark is also a platform. Spark, so just like Yarn, Spark has its own platform. Okay, you can use Spark's default platform, or you can tell Spark that work with Yarn. Okay, so there are multiple things. So what your Spark can do, your Spark can run in standalone mode. In standalone mode, your Spark uses its own platform. Okay, you can tell Spark to run on Yarn. Spark on Yarn. This is also possible. Okay, with this route, your Spark gets integrated with your Hadoop. There is one more platform. I mean, it's not used by us. There's a platform called as Mesos. It is similar to Yarn. It's again a cluster management platform, but it's not used in Hadoop. Okay, it's a cluster management platform still. Okay, Spark can run in standalone in Yarn mode, and Spark can run on Mesos also. So it's just a functionality provided with Spark. Okay, Spark on Mesos. But if you're using Spark with Hadoop, you will just use this route. Spark on Yarn. If you talk about Spark standalone, okay, this piece is pretty stable. Okay, Spark running standalone, this piece is pretty stable. Your queries, very rarely the queries fail, but Spark on Yarn is a piece which your Spark team needs to concentrate on. It is still getting matured. Okay, so Rahul says, what benefit we get with Yarn? So the benefit is you can use Spark on your existing Hadoop cluster. When I say Spark on Yarn, that is basically Spark with Hadoop. All right. So your existing tools like Hive and Pig, which is processing your data using MapReduce, you can process that data using Spark. The advantage would be speed. Right. Okay, so it can build and run applications that combine different models. It provides supports for different types of data. So it can work with JSON, Paraquet, Hive tables, etc. Yeah, so Chaitanya says it has master-slave architecture. Yes, it also works as a master-slave architecture. Okay, so we'll be going to the architecture in coming slides. So it provides different types of data like JSON data, Parakeet, Hive tables, etc. So again, Spark you can use for structured, unstructured, and semi-structured, all types of data, all varieties of data. Okay, it comes with an interactive shell also. Okay, just like your Hive, just like your HBase, just like your Pig, where you had an interactive shell, your Spark also comes with a interactive shell. Spark streaming can be easily integrated with high throughput frameworks like Kafka. Again, Spark streaming is, I can say, one module in Spark which can process real-time streaming data. Right? So there are frameworks, there are tools which can fetch real-time data. And the most famous tools are Kafka and Flume. These can fetch real-time data. Okay, so Minay says, does it also works with Amazon Kinesis? Yes, it does. All right, you can use Spark streaming with Amazon Kinesis also. Okay, so Kafka, Kinesis, Flume, these are all tools which fetch real-time, high-throughput streaming data. Okay, now see, if you talk about Hive, what we do in Hive or what we do in Pig, we have a table and we write some queries on that table. Now, when we say we have a table, that means that data is already there in HDFS. Okay, but let's say my use case is different. Let's say my data is not there in HDFS, it is coming to HDFS from a source. Let's say this is my source. Let's say this is a website which is generating some data. This is my Hadoop cluster. This is my Hadoop cluster. If I want to, the data which is generated by this cluster, by this website, sorry, if I want to do some processing using Hive or Pig, what needs to be done? This entire data should be moved to HDFS. And on HDFS, I would create tables, or if I'm using Pig, I would be creating files, and I'll be running my MapReduce jobs. Now, with Spark, Spark gives you a component in which you can process streaming data. Now, what is streaming data? So this is streaming data. The data while it is coming, okay? The data while it is coming, you can process this data in the stream itself. So you can use tools like Kafka. So Kafka basically gives you a channel. Okay, it's too messy. Okay, so Kafka basically gives you a channel on which this website will post data, Hadoop will pick data. On this channel, you can basically create a tab and do some Spark processing, real-time processing. Now this processing while my data is coming, this functionality was never there in Hadoop. Right? Spark has added a component which is called as Spark streaming, right? In which it can process real-time streaming data. So if you want to process and work with real-time data, Kafka and Spark, this is a deadly combination. Okay, Kafka with Spark is a very extremely deadly combination in which you can process real-time data using Hadoop. Right? So such functionalities which your Spark is giving, which was not ever there in Hadoop. This is the reason why everyone has started shifting their focus to Spark. That's why there is lots of requirements for Spark developers. All right. So this is all the tools, all the components of Spark. So at base, your base is Spark core. That's your core Spark engine. Yeah, so Minay says, you mean everyone wants real-time analysis than batch processing? Yeah, if you're talking about social network and the data age in which we are living today, everyone is looking for real-time data processing. That's why everyone is shifting their focus. Okay, now this is the core. Okay, now this is your core heart of Spark, Spark core. Okay, this is your basically Spark engine. right? There are lots of components in Spark. Now, one of the component is Spark SQL. Now, basically, Spark gives you an SQL layer on top of Spark. Correct? Like Hive is giving you an SQL layer on top of MapReduce, right? Spark SQL, it gives you an SQL layer on top of Spark. So you can write SQL queries, it will convert to Spark and then run it on your cluster, right? Basically in memory. Now the best part with Spark SQL is, so if you talk in terms of language, Spark SQL is a bit different than your normal Hive SQL. Some changes, not much, a few changes are there, okay? But it is still compatible, there is no issues, right? The best part is, with Spark SQL, like inside your code itself, you can create tables, create temporary tables also, which was not there in Hive. Let's say I want to create a temporary table for querying, okay? And when my session finishes, I don't want that table anymore. This is not possible with Hive or any Hadoop tools. With Spark SQL, it gives you functionalities like creating intermediate temp tables on which you can query, and when your session finishes, that table is gone. It is not persisted to the metastore, right? So this is one advantage of Spark SQL is giving. Another advantage of Spark SQL has is your Spark SQL can integrate with Hive. When I say it can integrate with Hive, that means if you create a table in Hive, that is automatically visible to Spark SQL. That means the metastore is shared, right? So this is possible with Spark SQL. Now there is one more component in a Spark is Spark R. Now for those who don't know R is a language which is an statistical and analytical, it is used basically by data scientists, right? Data scientists, data analysts kind of guys. To do some analysis on your data, for example, statistical analysis and those kind of things which you need to do data science stream, there is a tool called as R. It's a language which you can use, right? So R, it runs standalone also. It's just like Java. You install Java, same way you install R. Best thing with Spark is you can run your R code using Spark on your Hadoop cluster, which will run in memory, right? So Spark gives you a component called as Spark R. Spark integrated with your R language. Now the next thing is Spark GraphX. This was the thing I was discussing about, your graph processing. So your Spark gives you a component for processing graphical databases. The other thing we just saw is Spark streaming. A Spark can be used for processing real-time streaming data. And then you have mlib, that's basically a machine learning library. Internally, your Spark can work with these kinds of clusters. Your Spark can run standalone, that is without Hadoop, and this standalone can work on Windows also, Linux also. Spark can work with Hadoop, that's your Yarn, Spark on Yarn, and it can work with Mesos also. Okay, so Mesos is not the area which we are concentrating, just a additional thing. Spark is designed to work with Mesos also. Mesos is similar to Yarn. It is a cluster, it's a platform, okay? Cluster managing platform. Okay. Now one thing with Spark. Now if you see, we have been discussing about lots of tools, right? And if you notice, I was telling you which language this tool is written. So up till now we have seen everything is written in Java. MapReduce written in Java, HDFS written in Java, Zookeeper, Hive, Pig, HBase, everything is written in Java. But Spark, okay, Spark is not written in Java. Okay, Spark is written in a functional language which is called as Scala. Okay, Scala or Scala, depends on the pronunciation. Okay, so Spark is built on Scala. So Scala is a language which is a functional programming kind of language, right? It is similar to Java. Okay. Now, if you have experience working with Java 8, Java 8 also gives you functional programming things, right? Like the Lambda functions and all. So if you're familiar with Java 8, then Scala is simple, right? But if you're not familiar, then I would say you will struggle a bit in learning Scala. But the best thing is to use Spark, Scala is not always required. All right. There are multiple languages in which you can use Spark. See, when I was talking about MapReduce, so I told you can write a MapReduce job in Python, Java, .NET, C#, any language. But with Spark, there is a fixed set of language you can use. You can either use Scala, which would be the fastest language because your Spark itself is written in Scala. You can use Java or you can use Python. Right? Only 3 languages you can use in Spark: Scala, Java, and Python, and R also, of course, R also. Right? Now, what is Spark Core? So it's an execution engine of Spark platform. All the functionalities of Spark are built on top of this core. It provides APIs to define resilient distributed datasets. Right? Now this resilient distributed datasets, this is basically the core of Spark. This is the heart of Spark. We will talk about this in the coming slide. Okay, it is abbreviated as RDD. Okay, resilient distributed datasets, RDD. Okay, it supports Java, Scala, Python API for developing wide range of applications. Right? Edureka has a course for learning Scala also. Right? So Scala is not like in 1 to 2 days you will learn Scala. Right? It will take some time to learn it. You can do it yourself or you can apply for a course. Right? Now what is Spark SQL? So Spark SQL is a Spark package on top of core to work with structured data. Okay, it provides interactive SQL queries to explore data. Okay, it defined data frames. This is what I was talking about. So you can register temp tables. So whatever intermediate outputs you have, which you can register as temp tables, Spark stores that into a data structure called as data frames. Right? And these data frames are basically, it's not on a single machine, right? If I talk about a 10 GB file which is there on HDFS, it is distributed across multiple machines. If I load that 10 GB file in a data frame, that data frame won't be on a single machine, it would be distributed. So data frame is a distributed collection of data, right, grouped into multiple columns. So you can consider this to be a table, data frame, you can consider this to be a table which is distributed across your cluster, a distributed table kind of, because my file is distributed across the cluster. And it also supports Hive SQL. Okay, so you can integrate Spark with Hive SQL also. Then you have GraphX. GraphX, it's a computation engine built on top of Spark, and it provides an efficient Spark API for building and processing graphs. Okay, it extends RDD of Spark. RDD was the resilient distributed datasets, which we would be discussing, for graphical parallel computation. Right? Extensive supports of algorithms, which eases the tasks of graph analytics. Right? So it depends on a use case. If you have a use case for processing graphs, then you would choose this option. Otherwise, you will never use GraphX. So Spark streaming. So it is built on top of Spark to process and analyze streams of data in real time. Okay. It represents stream of data with sequence of RDD. It can be easily integrated with high throughput, low latency frameworks. Okay. So if you see, you can integrate Spark streaming with Kafka, Flume, S3, HDFS, Kinesis, and Twitter. These are a few examples. You can integrate with other tools also. Then you have machine learning library and you have R library. Okay, just I'll read this. A scalable machine learning library built on top of Spark. uses a Scala NLP. That's a natural language processing. You can use it for scientific computing, machine learning, uh, those kind of things. Okay. It is inbuilt with extensive algorithms, including regression, clustering, and a lot of other components. Spark R. So Spark R is an R interface built on top of Spark. It exposes components like data frame RDDs into R, and it provides a lightweight front end. So Spark, so this was what I was mentioning. Spark, if you are developing a Spark code, you can write it in only 4 languages: Java, Scala, R, and Python. Okay. So history of Spark. So it was developed at University of Berkeley in 2009. It was started by Matai Zaharia and open sourced in 2010. So Spark was open sourced. It came to Apache in 2010. It's written in functional programming language Scala, right? And uses AKKA. AKKA is basically a serialization library. Okay. It was developed along with Mesos, which is a cluster management framework. And in 2013, it came to Apache. Okay. Spark went on to become top-level Apache project in March 2014, and Spark developed by targeting interactive, iterative computations like machine learning. So remember, if you're having an iterative kind of processing, Spark is the best thing to use. Okay. This is all about the versioning information. Okay. So what happened in every version? So that's fine. Okay. So Apache Spark is not compatible with existing Hadoop framework. Is it a true statement or a false statement? Yes. So everyone says it's a false statement, and that's the right answer. Okay. What are different clusters supported by Apache Spark? Mesos, Spark Standalone, Yarn, or all of them? Yes, all of them. Right. Everyone gave the right answer. Right. So let's see how to download and configure Spark. So what I've done is, so I have a different VM for Spark. Right. So until this starts, we basically move on the next slides and we'll come back to this demo again. Right, invoking Spark shell. So I'll tell you how to invoke it after we'll see the installation part. Okay, so Spark is easy with Scala. Okay, not easy to be specific, but faster. Okay, see, if you're using Hive or if you're using Pig, right, you will not get as good performance as you will get using a Java MapReduce. The reason is your Hadoop your MapReduce is written in Java. So whatever you're writing in Java, your MapReduce will understand this very quickly. But the moment when you turn up to other frameworks like Hive, so Hive is giving you an SQL layer. So there is an extra processing of converting your normal SQL queries to a MapReduce job. There's an extra layer of conversion. If you talk about Pig, there's an extra layer of conversion of converting your pig scripts, pig Latin code to your MapReduce. Like if you talk about writing a MapReduce in Python or in C#, any language, there's still an extra layer of conversion involved. So the most fast your MapReduce would be, that would be in Java. Same applies to Spark. Fastest Spark will work with Scala, right? So what is Scala? So it's a general purpose scalable programming language aimed to implement common programming patterns in a concise, elegant, and a type-safe way. Supports object-oriented and functional programming styles. Okay, functional programming as in, so if you're good with Python, you must be knowing the Lambda functions, right? That's a functional programming piece. So ideally, Python is also a combination of object-oriented and functional programming. Similar, Scala is. Okay, it was publicly released in 2004 on a JVM platform and then on a .NET platform. The best thing with Scala is in terms of execution, Scala is similar like Java. So when you compile a Java code, it gives you a bytecode, right? A class file. Same happens with Scala also. In fact, the command is also same. How do you compile a Java code? You say Java C. Same thing, if you want to compile a Scala code, you say Scala C. Right? Ultimately, Scala runs on a JVM. Right? Scala runs on a JVM. Okay, so there are lots of similarities between Java and Scala in terms of execution. Like if you talk about garbage collection, your data types, data assignments, all of these things, it's very similar to Java. Right? Why Scala? It is type interference, runs on JVM, which means Scala is completely interoperable with Java, growing new types and control constructs, functional and also object-oriented, allows to define implicit conversions, powerful library and API, and it has most of the powerful frameworks like Spark and Kafka are written in Scala. So Kafka is also written in Scala. Okay, Flume, that is written in Java, but Kafka is written in Scala. So ultimately, Scala is compiled to a bytecode that's a class file and runs on JVM. So Scala is also platform independent. All right. Okay, just a quick overview. What is functional programming? So apart from being a pure object-oriented programming, Scala is a functional programming. It is driven by two ideas. First main idea is that functions are first class values. Okay, they are treated just like any other types, say string, integers, etc. So you can define a function and use that as a string or an integer, other things like you can write a function within a function, okay, which is not possible in Java until Java 8. This is possible in Java 8. Okay, because Java 8 has introduced concept of lambda functions. That's basically a function inside a function. Okay. The second idea of functional programming is that the operations of a program should map input values to output values rather than change data in place. This results in immutable data structures. So I'll tell you, if you work in Scala, Scala also looks like it has a left-hand side and a right-hand side. Right? In Scala also you will see left-hand sides and right-hand sides. Right? Every right-hand side, if you talk about pig, right? Every right-hand side was a transformation. Again, so every right-hand side is a transformation which results into a data type or a variable, you can say. And similar to pig. Okay, let's say in pig, what I do, I define my entire flow, right? A equal to something, B equal to, I use A in B. I transform A to get B. Then C equal to, I transform B to get C. Right? Similarly, let's say D is my final output, which I'm achieving from C. Now, if you look this piece of code in terms of pig, what pig will do until I dump D. Okay, until I dump or store D, my processing will never start. correct? Same thing happens with Scala. You define your steps, and at the last, when you're doing and you're performing some actions on your variables, some on your data, it will then compute and run in actual. Okay, so there are two things in Scala. First is called as a transformation, and second thing is called as an action. So if you're transforming, it is not processing data, it is just storing, it is just creating a plan kind of a thing. And as soon as you call an action, okay, an action in terms of Scala could be, let's say you want to print that final thing. Okay, if I write that in a print statement, or if you want to count, those kind of things that turns up to be an action. So if you perform any action, then is the place when your actual transformation should be compiled into a bytecode and run onto a JVM, right? Okay. So the results in the this results in an immutable data structure. Okay, so when I say A equal to something, if we talk about this, so you can transform, let's say I got B, you can transform B, but you cannot change B. I cannot say B equal to transforming B. I cannot say this, right? So this happens in Pig also, right? So you can, so all the left hand sides which you are getting, these are non-changeable, these are immutable, right? Okay, now Scala gives you a REPL loop. Now what is REPL? It is basically read, evaluate, print loop. Okay, don't get confused with such a heavy term. It is just an interactive shell in simple terms. You open a Scala shell, you give some commands to a Scala shell, it will immediately process and give you the output. If you're doing an action, of course, it will immediately process and give you the output. That's a read, evaluate, print loop. It's an interactive shell. So it is an easiest way to get started with Scala, acts as an interactive shell interpreter. Even though it appears as interpreter, all the codes which you type here is converted to a bytecode and executed. How to start Scala? Scala and enter. So for example, if you, in your Scala shell, if you just type 10 plus 2 and you hit enter, immediately it will, on the same thing, it will read that code, it will evaluate, it will print their output. That is REPL. Right? If you write 10 plus 2, it will immediately give you an output 12. And it will automatically identify the data type for this. So an automatically generated or user-defined name to refer to the computed value. So if I don't give a value, right, I just say 10 plus 2. I did not assign it to any variable. So your Scala will automatically assign its own system variables. For example, RES0. Okay, so Chaitanya says, any service to be run for Scala? No. Scala is just like your normal Python. So if I want to run a Python code, I just enter into a Python shell and I can start coding without starting any service. Same thing. Right? No service to run for Scala. But for Spark, yes. Okay, for using Spark, you would be running a Spark service. So Manish says, what is an extension of Scala? SC? No, it is .scala. Okay, similar to .java, it is .scala. For Python, it is .py, but for Scala, it is .scala, full name. Okay, so it automatically, when I say 10 plus 2, it will automatically give me the output. If I don't assign it to a variable, it will automatically assign res0, which means result 0, a colon followed by type of the expression. So it gives me the type also, an equal to sign, the value resulting from evaluating the expression. So this is a normal shell, okay, nothing much. Okay. This in terms of Scala is called as REPL. All right. So even though Scala is a functional language, it does not support object-oriented paradigm. Is it a true or a false statement? So everyone says false. That's the right answer. Okay, so before going to the demo, this thing is very important to discuss. Okay, now what happens in Spark is, so let's say if you talk in terms of Java, if I want to do any processing on a particular class or something, what is the first thing I need to do? Like if I want to do some processing on a class which I have written, can anyone tell me what is the first thing I need to do? Chaitanya says import. Okay, I import. Then can I start processing if I import? What is the basic thing in Java which you do? Okay, so Rahul says you define a main. Chaitanya says you declare a class and a main. Okay, that's a prerequisite. But define a main also does not start my processing, right? If I want to process something specifically, okay, what is my start point? And it's very simple. Yeah, there you go. Right? So Rahul says object. Chaitanya says compile. No, you load an object. You create an object first, right? If you want to work with Java, if you want to use a class, I would create a class. I would create an object of that class and then I would use it. Correct? Similar things apply to Spark. If you want to use Spark, the entry point of using Spark is a class. So Spark has written a class in Scala, of course, and that class name is Spark Context. Right? This is the entry point for your code in Spark. So either you use Spark SQL or you use, okay, not Spark SQL. Spark SQL is normal SQL. So either you use, let's say, Python, or you use Java, or you use Scala, or you use R. The entry point for your code would be creating an object of Spark context. All right. Now there are different types of Spark context available. Okay. So you can consider what they have done is Spark context is a class, and they have multiple subclasses of the Spark context. Okay, just like the inheritance fundamental in your Java. So your Scala is also an object-oriented, right? So it also has an has your object-oriented fundamentals. Okay, so you have different types of Spark context. So one of the type is streaming context. Then you have SQL context. Then you have Hive context. Right? So this means if you want to use Spark streaming, then the entry point would be you have to create a streaming context. So you would say Spark context, and in whereas SC equal to new streaming context. Same Java way of coding it. Right? If I want to use Spark SQL using my code, see, Spark SQL means two things. Either you can directly write an SQL statement, that's an interface Spark gives you, and other thing is you can trigger SQL queries using Python or using Java or using Scala. Is also possible. So for that, you would create a SQL context. So it's a Spark context SC equal to new SQL context. You can also create a Hive context. Now, what is the difference between SQL context and Hive context? Hive context knows your metastore. So if you use a Hive context, a table created in Hive would be automatically available to your Spark. So any point in your Spark code is your Spark context, right? So any Spark program starts with creation of Spark context objects. which provide a way for Spark on how to access the cluster. It is represented as SC, stands for Spark context. Okay. Now you can start a Spark context in local mode with multiple threads. In a Spark cluster, as in the standalone mode, where you don't require Hadoop, but still works in a cluster, in Mesos or on a yarn cluster. Right? So let's see what is on the next slide, and I'll tell you how to install. Okay. Next thing is RDD. I think we won't discuss RDD in this session. It would become too much in Spark if you discuss RDD also. Okay. So I would stop with the slides. What I will do is I'll show you about some practicals about Spark. So I'll take around 10 minutes more. So what I have done here is, this is my Hadoop cluster. First, let me start Hadoop. Okay, Hadoop is not required actually. It's Spark standalone. I'm running in local mode, so Hadoop is not required. Still. Okay, now to start using Spark, it is very simple. For installing Spark, what you do is you just download a version of Spark, unzip it, and Spark is installed. That's it, nothing much. But a prerequisite is, if you are installing Spark, the first thing you would be installing is Scala. Right? So the first thing you would be doing is you would be installing Scala. So Scala is available directly on the internet. You'll just Google for Scala download any version of Scala, unzip it, and install it. Install it as in just add that Scala location in your set a path of that Scala, set Scala home. Right? Then you download and unzip Spark. Now if I do that, so I've already downloaded Spark. And I've just unzipped it and placed it at USR local Spark. Right? So I've just placed my Spark. I've just extracted Spark here. I haven't done anything fancier. Oh, what happened? Okay, so just extract Spark here. Now in your bin folder here, you will find various types of shells. So Spark by default comes with a Spark shell, which is basically will give you a Scala environment, right? Spark shell. You will also have a Python environment. So if you say PySpark, it will start Python environment for Spark, right? So Minesh, one thing interesting for you, right? So I'll just so I'll just start this. So I'll go to this location and I'll just say Spark shell. Now the best thing with this shells, if you're dealing with a PySpark shell or a Scala shell, the best thing is this Spark context and this SQL context. This is automatically instantiated and the object is available to you. Like if you're, let's say you're not using a shell, you want to write a code in, let's say in Eclipse, right? You are writing a real-time code or in a Python environment. So the first step you would be doing is you would be importing the Spark context and creating an object of the Spark context. But if you're dealing with this shells, if you look at if you read the logs carefully, it will say Spark context is already available as SC. It will also tell you SQL context is already available as SQL context. So I'll show you in the logs. It's taking some time to start. Okay, so if you see Spark context available as SC. So there is no need to instantiate Spark context. You can start coding directly. All right, so Rahul says, is it a web server? No, so what it does, Rahul, is, so when you will submit jobs on a Spark cluster, it has a web page on which you can check the status of the job. Similar to your Yarn, okay? Your Yarn basically gives you a resource manager UI for checking how many map reduces are running, how many containers are running, and those kind of things. So Spark also gives you that kind of a UI. It's a single node small VM, that's why it's taking us a lot of time to start. All right, see if you see the log, SQL context available as SQL context. So you can use this SQL context variable and you can start writing an SQL code. So here I enter into Scala. Just an example which I was showing in the slide, REPL loop. So if I just said 10 plus 2. So Scala is not so much slow, right? My machine is slow. Okay, see it gave me the output. All right, so this is my Scala shell. Now let's say I want to use some Spark coding. Okay, so 10 plus 2, is it a Spark job? It is not. It is just a Scala normal thing. When it will be a Spark job, when I would be using and I would be coding against Spark context, right? For example, if I say what kind of thing I should do, let's say I read a SQL, I use a SQL context, for example. So it is already available as SQL context. Let me trigger one simple query, which does not require a table. There's a method called as SQL context.sql. I'll give a simple query, select one. It does not require any table. Okay. Dot collect. It's a Scala language. So I will just hit enter. Now this will trigger a Spark job because I'm using a SQL context. Ultimately, a Spark context. Right? Now what happens with Spark is whatever jobs you run, okay, you can track the status of the job on a web page. The web page automatically runs on the port for 4040, right? 4040. So everything here is local. So I'll just open that page for you. So when this page would be available, when Spark context would be created. Okay, if you don't start Spark context and you start looking at localhost 4040, you will see nothing is found, page not found. This page is created when Spark context is available. This also means if I'm using a local cluster, I cannot create multiple Spark context, right? I cannot create multiple Spark context. I cannot open 2 sessions of Spark in my machine. Okay, so this is my output. Okay, it gave me an array. So let's check the shell. So see, this is a Spark UI, Spark shell UI, right? Now, if you see, there are lots of tabs available here. Okay, it created a job. This is my job. Now, this job can have multiple tasks. In my case, I was just doing a select one, so there was only one task. Okay, now if I click on this, it's slow. Right, so if I click on this, okay, so see there are some details available here. So if I click on details, now this details would be specific to Scala language. So if you know Scala, you would be able to figure out some things which are mentioned here. Right, it will give you some log kind of things. Right, so it gives you details about how much duration this query took. Okay, if I'm working in a distributed cluster, so how much data, how much network was used, how much shuffling happened, how much input was there to this particular query, to this particular stage, you can say. Right? Everything would be mentioned here. Right? Now, so if my query is very complicated, so what Spark does is, so remember Pig, what Pig does for every statement, it creates a plan. And when you say dump or store, it builds the plan and runs it. You can also see the plan in Pig, right? You can use an explain statement. With Spark, the same thing is done visually. So Spark, what it does is, the plan which Spark creates is called as DAG, DAG. It's an abbreviation for directed acyclic graph. Okay, basically it's the tasks which you are doing. So if I have multiple tasks together, how they are connected, that basically forms a DAG. So there's a DAG visualization here. So if I just open this, so this is what my Spark did for my query. This is again Spark specific terms, parallelize, project, map. If I click on these small dots, it will take me to further details. Right? See, these details, it's abstracted. It's very much in terms of Spark and Scala. So you won't be able to understand everything, but yes, you would be able to see that my tasks, is it running process local? Yeah. Okay, so shift that says subject is 2 AB. Let's do one thing actually. I'm also feeling that I'm telling you lots of things about Spark, which is too early. I mean, Spark, if I bombard everything of Spark in, in a 1 or 2 hour session, you will understand nothing. So let's do one thing. Let's stop for today. Right? Let's stop for today. Next time onwards, so we'll start with RDD. So I'll tell you what is planned for the next Saturday. So we'll start with, we'll discuss about RDD, and I'll give you demos. So what I'll be doing is, I'll be showing you this UI in details. Okay, I'll be sharing this UI in showing the details of this UI. Then I would be running a word count, which I did in MapReduce. I'll be running a word count in Spark, right? Using Scala, right? I would be running that on a local file also, on a HDFS file also. And when I will be running it on an HDFS file, I would compare the speed of MapReduce versus Spark. Right? So you will get a clear understanding on the same cluster I will do. Okay. So even if the cluster is slow, both the things will run slow. So still you'll get a clear understanding that Spark is fast. Right? Okay, guys. So let's stop for today. Okay, so I would require 1.5 hour for Spark, and then we'll start with Uzi. So probably next Saturday we'll try to finish. If not, by any chance, it may spill to next Sunday also. Okay, but be comfortable. Everything would be covered. I mean, I won't skip anything. Sorry, I won't skip anything. Everything would be covered. All right. Yeah. Thank you, Manish. All right, guys. Thanks. Thank you, everyone. Have a good night. Right. I hope this was helpful. Okay. Just a reminder, please fill in the survey. Yeah, it would be I would appreciate that. All right, guys. See you next week. Have a nice week ahead. Good night. I'm still available for next 5 minutes. Okay, so if you have any questions, you can post it. Yeah, so Shiv Prasad says, can we practice Spark on our own? Yes, Shiv Prasad, you can. Actually, you should practice. The Spark is one thing. Unless you get your hand dirty using Spark, you won't understand Spark. I recommend highly you should practice Spark. Okay, installation wise, it's very simple. Okay, so getting started with Spark is very simple. So Shiv Prasad says Scala language. It depends. If you're comfortable with Python, you can use Python. If SQL, then you can use SQL, right? Or you can also use Java. I would say if you start using Scala, you would find it. I mean, personally, my experience, I found Scala in the first look, it was complicated, right? So it took some time, but yeah. So I would suggest start with Python or Java or SQL, of course, okay, and then slowly move on to Scala. But even if you will be writing in SQL, right, you would still require a Python code or a Scala code. See, it doesn't matter. I mean, so as I mentioned, right, if you just enter into the Spark shell, you have an SQL context available. If you just open Spark guide, it's available in LMS also, it's available in your Apache website also. So the Spark guide tells you how many methods are available with your SQL context. Okay. For example, I used one method, SQL context.sql. .sql is a method. So there are multiple methods available. Okay. Ideally, you would be using .sql only. So you can simply start Spark shell, which would be a Scala shell only, but you won't code in Scala. You will just say SQL context.sql, and in brackets, you will be specifying your queries. Okay. So you can try creating tables, temporary tables, you can try querying the tables, you can try some complicated queries, multiple tables, multiple joins, that kind of things you can try. Okay, so if that says, can we totally depend on Spark SQL? I would personally say not really. The thing is Spark SQL, and if you consider Scala and Python, is if you're running Spark SQL, you don't have control over the intermediate steps. For example, I mentioned every step in Spark SQL creates something called as a data frame, an RDD. Okay, if you're using Spark SQL, we cannot control. For example, control as in, so I was talking about caching, right? So if you use Spark SQL totally, Spark SQL does not gives you control over caching and all. So all your application specific things like caching and doing some aggregations on your data, you cannot totally rely on Spark SQL. See, ultimately you would be triggering SQL only, but through a programming language. The way I just triggered, SQL context.sql. That will return you a data frame, and that you can cache. You can register as temp table. So all of these things should be, so it's basically a combination of SQL with a programming language. So actually we also don't use Scala, we use Python. We use PySpark. Scala is required, depends. I would say not really. So there are options, right? Scala, Java, Python, or R. Anything, any one of these. Okay, so which one is better, Scala or Python? See, methods wise, both have the same number of methods. It's just your preference. Chaitanya says, can we manage with Java? Chaitanya, one thing I noticed with Java is if you use Python or Scala, there is very less code to write. But if you use Java, there are lots, the code is very huge. So for doing a small thing, you have to write 5-6 lines of code, which can be done in a single line in Spark, in Scala or Python. Shiv Prasad says, which one is easier? See, according to me, Python is easier. Okay, Python is easier than Scala. If you know Java, Python is simple. Okay, but still, okay, so if you don't know Java, but still Python, any language, you know, any programming language other than SQL or something? Oh, then you would require some, some time to learn Python also. But if you're starting it for the first time, then with a programming language, then I would prefer Python, not Scala. All right. All right, guys. Yeah, so Java is not required to learn. Yes, true. Right, guys. So I'll be dropping off. Right. Happy week ahead, everyone. Good night.